So we have a mixture. We're going to put it in this container that contains 1.22 grams of xenon and 0.675 grams of nitrogen dioxide. And it's got a pressure of 1.44 atmospheres. So that's going to be my total. So if you remember Dalton's law of partial pressures, the P total is going to equal the pressure of NO2 plus the pressure of xenon, because pressures are additive like this. We also know that if we increase the number of moles, then the pressure also increases. So these are directly proportional. In other words, if we have PV equals nRT, and we set it equal to R, PV over NT equals R, that means that if I have P1 V1 over N1 T1, that also equals R. And if everything else is the same, which it is here, and we just want to look at pressure and moles, then temperature and volume cancel out. What I end up with is P over N equals P1 over N1, or you could use any designation there, but you can now see the direct proportion. As moles increases, pressure increases. So what this means is that the pressure of NO2 over the moles of NO2, that's going to equal the pressure of xenon over the moles of xenon, and that's also going to equal the pressure total over the moles total. That's because the conditions of temperature and volume are the same. Okay, so we're going to use these two equations to kind of help us out here. The first thing we want to do is figure out the moles of xenon, and then we're going to figure out the moles of NO2, and then we're going to figure out the moles total so we can plug it into our equation here. Okay, so the moles of xenon, it says that we're given 1.22 grams of xenon. We're going to change it to moles. So 1 mole xenon over 131.3 grams of xenon. That's going to equal 0.00929 moles of xenon. Okay, so let's do NO2, sorry. NO2, it says we have 0.675 grams of NO2. Change that to moles. 46.0 grams. Okay, and that's going to equal 0.0147 moles NO2. So my total moles is going to be 0.00929 moles of xenon plus 0.0147 moles of NO2, and that's going to equal 0.0240 moles of gas. That's going to be my total. All right, so we're getting there now. Let's move this up a little, get rid of that. All right, so what is it we're looking for? Let's kind of see where we're at now that we have moles. We want to know we're looking for PNO2. That's what we're looking for. Okay, so we're going to look for that, and we're going to use this equation that we've got right here. Okay, so what do we know? Well, we are looking for the pressure of NO2. All right? So if we were to take the total and the NO2, we would, and rearrange that equation, solving for PNO2. PNO2 is going to be the moles of NO2 times the pressure total divided by the moles total, which we just found. Okay? So what we get for moles NO2, we've got 0.0147 moles NO2. That's what we figured out here. And then the pressure total, we have that. Is that given? It is. This is our total pressure right here, 1.44 atmospheres. Let's get him. That might have been a little tricky in the wording to figure out that that was the total. And then we're going to divide that by the total moles, which we just figured out. That's 0.0240 moles of gas. Okay, so the pressure of NO2, when we do that, turns out to be 0.882 atmospheres for NO2.